Alright guys, in exercise 3 it says that we're going to be dealing with a Ferris wheel, and it is constructed such that a person gets on the wheel at its lowest point. So already, even though we're told this by the equation of the function, we know what type of function is going to be used because at time 0 we're going to be at the lowest point of the function. And since we know that the general behavior of our two functions, if I have a sine function it would look something like this, and if I have a cosine function it would look something like this over one cycle, I know that I'm probably going to be dealing with a cosine function that's been reflected over the x-axis because I'm beginning at a low point. So I should see this function be a cosine function once they start telling us more about it. It reaches its highest point at 130 feet above the ground, and they've told us that the low point is 5 feet above the ground. The amount of time that it takes to complete one full rotation is equal to 8 minutes. A person's vertical position y can be modeled as a function of time in minutes since they boarded t by the equation, and there we go, we see the cosine function. So what they want us to do is to sketch a graph of the person's vertical position for just one cycle, so that's important too. We only want to see one full cycle. Alright, if I'm going to graph this thing, I'm going to need to know what my d value is, what my b value is, and what my a value is. So we usually like to start with d. D is our midline, and that midline is going to be the average of our high point and our low point. So I know that the maximum value plus my minimum value over 2 will give me that midline. So it says that the maximum height we ever reach on this Ferris wheel is 130 feet, and the minimum is 5 feet. And then we're just going to divide that by 2. So we have 135 over 2, or 67.5 feet. So what we know now is that the midline of this function is going to be at 67.5 feet. So we figured out that midline. And now what I'd like to know is what my a value is. That shouldn't be too hard to find because we know that we can find our a value by either subtracting the midline from our maximum, or if I wanted to, I could subtract my minimum from my midline. And I know that regardless of what I do here, I'm going to get 62.5. So that means my a value is 62.5. That's pretty useful. And then the last piece that I need to find is b. b takes a little bit of a calculation. So since b is related to the period of the function, I'm going to start with my period equation. And I know that period is equal to 2 pi over b. So that indicates that I must know what the period of the function is. If I go back to the word problem, it says that the amount of time it takes to complete one full rotation is equal to 8 minutes. That's telling me that when I jump on the Ferris wheel and it goes all the way around and comes back to the bottom where it's time for me to get off the Ferris wheel, that takes 10 minutes. That's one full cycle of this function. So the period is 8, and now what I have to do is just solve for b. And we're pretty used to this. In blue, I'm just going to show the steps that we're actually doing here. So I'm going to multiply by b on both sides, multiply by b. That's going to leave me with 8b equals 2 pi, and then I'm going to divide by 8 on both sides. So hopefully we're to a point where we're just doing those steps all in one stage here, and we end up with 2 pi over 8 or pi over 4. So now I know what b is. And now I have all the components. I have enough information to graph this function. So what I'm going to do is I'm going to label my y-axis appropriately. I know that it only has to go as high as 130 feet. And I know that right in the middle of 130 and 0 is going to be 65. So then I can start graphing this thing. 67.5 is going to be somewhere around here, so that's where I'm going to sketch in that midline. If 0 is down here, then 5 is around here. So I've got my maximum graphed, I've got my minimum graphed. I know that I begin at my minimum. So the function starts down here at 5 because they said the person gets on at 5. and then I end up at 5 again after one full cycle. How long does that take? Well, they said that our cycle takes 8 minutes, so I'm going to put 8 there, which means this is going to be 4, 2, 6, just helping graph this and label my axes a little bit better. Alright, and now we have enough information to graph this thing. So if my minimum values are here and here, then my maximum value is going to be right in the middle, so I should have a point as well at 4, 130, which means my midline values happen at 2 and at 6, and now I can sketch this thing in. So it's going to look something like this. Alright, and it says to show the work needed to arrive at our answer. We've got all our work here to figure out what the period is. Just so that we're clear, if I wanted to write the equation of this function, I would say y equals, my a value wouldn't just be 62.5, it would be negative 62.5, because if I use 62.5, that's a positive value, and since this is a cosine function, a positive value for a would imply that we start at a maximum, but we don't. Remember, this thing's been reflected, so I have to account for that with the negative there. So I would have 62.5 cosine of pi over 4t plus 67.5, and that would be the equation of the function, even if they didn't ask for it. I know they just need the graph, but that would be our equation, and it's good to make sure that we're able to come up with that as well.